So, how can we ensure that our punch will have enough force to fracture our opponent's nose when we deliver that one big punch? Practice. Practice, practice, practice. That is how you will be able to develop your punch to make it strong enough to beat your opponent's nose. But that's not really enough. We need some sort of way to measure how strong our punch is, so we are certain that when we are faced with an opponent, we will have enough strength to break our opponent's nose. This gets me to my next point. I have designed a machine. I have designed a piece of technology that is meant for this exact purpose, that is meant to help prepare you for the moment that you may need to punch somebody in the face and break or fracture their nose. Let me explain. My machine will sort of be similar to an arcade machine, except the only difference is that my machine will consume way less energy than an arcade machine, because although we might be rough against our opponents, although we might be rough against the people who are trying to attack us, we can never be rough to our environment. We must be very lenient and nice to our environment, and that is really the aim and that's one of the goals of this machine, is to provide you with what you need while also, caring for our environment. According to a report by TIAX LLC, the energy consumption of an arcade gaming machine is estimated at about 10.2 kilowatt hours per day, and thus roughly 3,700 kilowatt hours per year. That's quite a bit of energy, right? The machine that I'm designing here will use way less energy than that, and again, that is to help our environment. So, what is my machine? How does it work? Tell us more. Here, I'll tell you more. The machine is basically a little something like this, okay? Obviously, it's going to be standing on the ground, so this is the stand of my machine, okay? And this is the ground right here. So, you, as someone who is practicing, is going to be standing right over here, okay? I'll write this a little bit. So, basically how this machine is going to work is as follows. The machine is going to look something kind of like this, okay? And I'm going to explain exactly how it works. So, basically, this right here, this circle that I drew, this is a punching pad. Okay, this is a punching pad, and inside of the punching pad is attached, it's going to be attached to a string. Okay, so we got a punching pad, the punching pad is attached to a string, and you are over here. This is you, smiling. Okay? The aim of this machine is basically to measure how much force is packed into your punch, and then to give you feedback, to tell you your punch is too weak, or your punch is alright, or your punch is good. Right? That's the aim of the machine. So that hopefully by practice, if your punch started off as being weak, by the end of it, your punch should be strong. Okay? This machine works as follows. There is going to be a sensor over here, a motion sensor that's going to be attached right over here. So this is the sensor. Hopefully you can read this. This is the sensor. Next to the sensor, we're also going to have a tiny screen. It's not going to be too big because it doesn't need to be too big. This is just going to be a tiny screen, and somewhere over here as well, we're going to have a calculator, a really, really, really small, really, really simple calculator that barely uses up energy. And so, okay, let's just get to the point. You, as someone who is practicing your punch, is going to punch this pad. You're going to punch this pad as hard as you can. What's going to happen to the pad? Because since it's attached to a string, this pad is going to go inside a little bit. The string is going to the spring is going to compress. So this pad is going to go from being here, for example, to being, let's say, right here. Okay? The pad is going to go from here to here. And the spring is going to compress this much. Spring is going to compress this much. This value right here, let's call this value the distance that the spring compresses. Let's call this value x. Okay? This is the x value. So when you punch the machine, the spring goes inside, and then the distance that the spring compresses inside, we're going to call that x. Okay? So far, so good. So far, so good. Okay. And now I might get a little bit physicsy here, so just bear with me, okay? Basically, if we were to draw a free body diagram, diagram of this pad in this exact position, if we were to draw a free body diagram, let's say that the pad is this dot. The pad is this dot, okay? At this moment, the moment when the pad reaches the uttermost distance that it could go, the moment that it goes as far as it possibly can, at that exact moment, the forces that are going to be acting on, keep in mind, at that exact moment, the pad will be stationary. The moment where it goes all the way in, and then it stops, and then it goes back. And then it goes all the way in, and then when you let go of your hand, the pad is going to come back. So that moment when it stops in the middle, but your hand is still on. Like your hand has plunged, the thing has stopped, that exact moment. What's the free body diagram looking like? The free body diagram is looking like this. On one side, you have the applied force by your punch, the FA. And on the other side, you have the FS, which is the force of the spring, the force being applied by the spring this way. At that exact moment, the FA, which is the force of your punch, and the FS are exactly the same. And then, right after, the next instance, what happens? This force completely goes away. Why? Because you let go of your hand. So the moment that your hand lets go, we're only left with this value, right? Are you keeping up with what I'm saying? So what this means is that if we are able to find what this value equals to, then we know what the value of the force of our punch is equal to as well. Because as we said during the moment before, these two are equal, and then we let go. But this is still for a moment it's staying the exact same as it was, right? Okay, I hope this is making sense. Okay, so what this means basically is if we find this value right here, this force of the spring value right here, then we also know the value of the force of our punch, okay? I know I'm repeating myself a little bit, but I want to make sure that the idea goes through, okay? So, how do we find this value? Let's work up here. Okay. So this value, we know that the force of a spring, Fs, or you might not know this, but here's some new information. The force of a spring is equals to F equals to Kx. And x basically is the distance that the spring compresses or extends. And we have this x already. Well, we don't have it, but okay, just bear with me. F equals to Kx, okay? This K value basically refers to how hard it is to stretch or compress our spring. And this K value, we're going to know this K value prior, because when we purchase this spring to put it inside of our machine, we're going to know the K value of our spring. Okay, so this K value is a constant. We don't really need to worry about that, okay? This K value, this X value is here. This X value is the distance between how the initial starting point of the spring and then the end point of the spring. What's the distance that it compressed? How do we find this X value? That is where this motion sensor comes into play. This motion sensor, which will be solar powered, it will be powered by solar energy, and motion sensors usually they use very, very, very minimal energy, so we're good with solar power. This sensor will measure how much the pad moved by. So the sensor will give us this X value. And then what's going to happen when the sensor gives us the X value? The sensor will send this X value to our very simple calculator that we're going to have right here. And the calculator will also be run by solar power. I mean, like, if I grab my own calculator here, this is a very complicated calculator, scientific calculator. Here it has a solar panel. This calculator, I don't even know how long I've had this calculator for. Didn't need to replace the battery, anything like that. Which goes to show that calculators in general use up very minimal energy, and this calculator will use even smaller energy because it's just a simple calculator, okay? So the sensor will send the X value to the calculator. The calculator will do the automatic calculation, and the calculation is very simple. It's just K, which is the value we already know, times X. The calculator will do this calculation, and then what's going to happen is the message will pop up on the screen. A message will pop up on the small screen, and the screen is also run by solar power because a really simple screen like that, just like the screen on your calculator, doesn't require too much energy to run, okay? And the screen will basically tell you the following. The screen will tell you what the force of your punch is. The screen will give you the force of your punch, so blah, 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 newtons. And then the screen will tell you, based on the force that you got, whether you have less than a 50% chance whether you have a less than 50% chance of fracturing your opponent's nose, or you have exactly 50% chance of fracturing your opponent's nose, or you have more than 50% chance of fracturing your nose. And these values will be based off of the research study that I previously talked about, which states that there's a 50% risk of fracture if the force of the punch is between 450 to 850 newtons, okay? And that's it. That's it. That's the whole machine. How you can't get any simpler. Although it might be a little bit complicated, like how it's built, actually using this machine will be so easy. You basically walk up, punch the machine, the screen tells you the force of your punch was blah 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 newtons. You have less than or equal to or more than 50% chance of fracturing your opponent's nose. And this machine will be a great way for practicing your punch, so that you ensure that if the time ever comes when an attacker attacks you, your punch has enough force to break or at least fracture their nose.